Hi, and welcome to another edition of Ordinary Differential Equation. We are going to still talk about domain of existence. Today I'm going to have a short video on one of these problems, and I'm hoping that you have already done that and you're just comparing your solution with the one we are going to obtain today. So this was one of the problems we talked about in the previous lecture. You remember we mentioned 4 problems. So I'm going to do problem D, and I'm going to leave this one for the last item because it's a little bit more involved. Okay, so remember our deal that you do the problem and then you compare your steps with what we are doing here. Step 1, this is separable, so we write it as Leibniz equation and then separate. Then we have to integrate this in the integral. So here we have integral. Let's write it in a format that is easy to remember. Y to power of minus 3, and here's dt. You remember, of course, any power, constant power, you have a simple formula. When it is a negative exponent, you better be careful that you don't get them wrong. So here is going to be y to power of minus 2. We go up by 1 over minus 2, and this side I'm going to have t plus c. And then we said at t equal to 0, y has to be y0. Of course, all of the discussion is going to make sense if y is non-zero. So y0 is non-zero for time being. Then we are going to consider that issue later on. So I'll have y to power of minus 2 over minus 2 is equal to t. By putting these entries in this equation, I get that c is y0 to power of minus 2 over minus 2 again. Okay, remember last time I gave a little bit of warning how to handle the negative exponents. So we cannot flip these things individually. You have to take common denominator and carefully rearrange. So let's do that step by step. So I multiply by minus 2, so I'll have y to power of minus 2 is equal to minus 2t plus y0 to power of minus 2. Let's write them in format that's more familiar. So it's y squared is equal to minus 2t plus 1 over y0 squared. Safest thing to do now is just take a common denominator and proceed like that. So I'm going to write y0 squared, and here I'll have minus 2t y0 squared, and then plus 1. Now it is legitimate to flip both sides. If I have just one fraction on either side, then flipping them is legitimate. And I'll have, I write the 1 first so that I'll use less symbols. That is standard in mathematics. Now I want to take square root. And I want you to carefully think about this thing. Should I write a plus or minus here or not? So I'm going to go ahead and write it, and then I'll ask you to think about that. Why is this correct, and why is it that I don't need any absolute any plus or minuses here? So y0 over 1 minus 2t y0 squared. So again, last time we said that if presence of these parameters is kind of unsettling for us, we go take a number like y0 is equal to say 5 and solve it with that, and come back and replace that 5 by y0 and do exact same thing. So what is it that I need here? I need to have 1 minus 2ty0 squared has to be what for the solution to be legitimate? It has to be, of course, a positive quantity. So that means 1 has to be larger than 2ty0 squared. So that tells me that t has to be less than 1 over 2y0 squared. That's our domain. Domain of existence is the t less than this quantity. So I hope that you have actually obtained the same solution yourself. Let's go ahead and play with our favorite software and see that it agrees with our answers. I have here the equation y prime is equal to y cubed. I go ahead and graph it. Here are my solution. Remember, y0 is picked out of this line. So we want to verify that what we got in our theoretical solution is going to match what we get here. It's a great engineering principle in the design is that when you design something, you consider a factor of 2 for safety. Well, when we come to this type of theoretical discussion, the factor of 2 is going to mean that you have the solution verified with 2 entirely independent approaches. So over here we have one approach, the theoretical approach, and here we have another one which is a software. And we better have an agreement between the two of them. So let's go ahead and check. Suppose I pick y0 to be 1. So if y0 is equal to 1, the domain of existence goes as far as 1/2. Let's see if that is going to hold water here. So if y0 is 1, now our hand's going to shake here. We're not going to exactly tap on 1. To be precise, you go ahead and open the keyboard input, and then I don't want 0.25, I want 1. Let's see what happens. So this one is picked at 0 and 1, and we see that the solution looks like it's extending all the way from all the way left, meaning minus infinity, and then at some point it explodes. At what point is it exploding? So if this is 2, this is 1, and this is going to be, well, it looks like eyeballing it that it's 1/2. That the domain of existence is from minus infinity to the t of 1/2. Is that what we have here? Well, yes. Here we said that if y0 is equal to 1, our domain of existence, this inequality means we go as far as 1/2. Well, let's try another one. If y0, say, is equal to 1/4. That's what I had there in that entry. 1/4. What would it be? Well, 1/4 squared. You square first, of course, and then multiply by 2. So you have to be careful here. So 1 over 2 times 1/4 squared. So 2 stays and the quarter is squared, and then this becomes 1/8, which is reciprocal of that is going to be 8. So what we are expecting is that our interval of existence, if I start low, I end up going much further out. Let's see if that holds water. So I go here. That's my so I go ahead and pick my solution. In this software, you cannot enter a fraction here. You cannot enter 1/4. You have to enter 0.25. If you enter 1/4, it's going to take it as 0. So 0.25, where's 0.25? Is somewhere down here. So well, I tapped on it, and that's not exactly 0.25. Let's see what happens if we actually let the software do it. So that's the correct place. That's quarter, and we see the solution starts from minus infinity and explodes at this vertical asymptote. Where is that asymptote? Is at 8. So that's good news that this 8 here matches the 8 that we have obtained theoretically, and therefore we have a confidence in our solution that two different things agreed and they look like we are understanding what's going on. Okay, so I'm going to stop this video, and I still expect that you guys go ahead and try the other problem. So I'm leaving that for last. For C, go ahead and find interval of existence and investigate it. It's going to take a little bit of algebra, but it's something that you have already done in pre-calculus, and so you should be able to do it. So for next time your assignment is to do that. That's like extra, and I hope you do it. Okay, good luck and God bless until next time.